Unit 8, Part 5, there's a typo on page 157. A logic textbook is basically the worst place you can possibly have typos, and this one is quite confusing if you don't notice. I know there's at least one of the answers where there's a typo as well, but I couldn't find it on a quick scan. But let me tell you about this one. So this is the discussion of conditional exchange, the rule that allows you to replace a conditional with a disjunction where the left disjunct is negated, or a disjunction with the left disjunct negated can be transformed into a conditional like this. Okay. The typo is here on 157. It reads, be very careful not to confuse statements of this form, on which conditional exchange can be used, with statements of the form this. That's exactly the same form as that, and you'll crack your head against the wall if you don't realize it's a typo, trying to find a difference. There is no difference. Those are the same. What she means here is not brackets P or Q. Okay, that's the typo. It should be not brackets P or Q. That becomes clear when she goes on to say, on which you can use De Morgan. What can you use De Morgan's on? You can use De Morgan on negated disjunctions, right? That is, there have to be brackets around the P or Q to make that a negated disjunction. And using De Morgan on it, you'd get a conjunction, not P and not Q. So that's a typo. Should be brackets around the P, open bracket around the P, close bracket around the Q. Okay, and so this is also important. This incorrect application of conditional exchange, right? This is incorrect because here again we have a negated disjunction, right? So to make this a correct application of conditional exchange, you'd have to remove this open bracket here, along with this one, right? You'd have to remove that because this would have to be, again, this is the kind of insight you get if you are saying the forms, the statement forms, as per their form, saying them generally. So read what she says here, right? Well, I was going to say, if you do remove this bracket here, and so the equivalent closed brackets here, then it is of the form what? Then it would be a disjunction with the left disjunct as a negation. It would be a disjunction with the left disjunct negated. That, you'll notice, is one of the two sides of conditional exchange. Okay, these replacement rules, if you're presented with a formula and you're asking yourself, can I or can I not use this rule, that resolves to the question, is the formula I have either in the left-hand side or in the right-hand side of that rule, right? Is it in either the left-hand side or the right-hand side of that rule? So if you're looking at this, you should be able to say to yourself, oh, can I use conditional exchange here? That's what she's warning you can't do, which you can use DM, but you cannot use conditional exchange. Question, if I've got this formula, can I use conditional exchange? Well, what form does it have to be in for me to use conditional exchange? Well, either this conditional or a disjunction with a negated left disjunct. But this is not either of those forms. What is this form? It is a negation. The major operator is a negation, which means the major operator is neither a conditional nor a disjunction, right? So this is not of the form a disjunction with a negated left disjunct, right? But that's what you do get if you remove this bracket and the closing bracket here. So see how her explanation in this following paragraph is given by a statement of the form of the statement, right? Saying what it is, where you're articulating its major operator, you're articulating its form, like I've been stressing throughout the whole course. What we could infer from the premise, what we could infer from this premise, but by De Morgan's, would be, right, from here, this is it. So here again, right, you need to see this as the happy face emoticon, as I said in, I think, part 4, right? This is a negated disjunction, right? You're in terms of what you have to see forms in instances, you abstract from the A, you abstract from the B hook C and its complexity, right? All you see is negated disjunction, right? That's the form. And that is the happy face emoticon. Why? Because its result is not A and, not brackets B hook C. And of course, if you derive this from this, then you can simplify and have not A by itself, not brackets B hook C by itself. There's another habit for formulas of this form, which involves doing conditional exchange on the subformula B hook C, which gives you what? Not B or C, and then ho-ho, another happy face emoticon, right? Then you've got not B and not C. You'll see that in practice in some of the exercises I do for you later. Okay, what we could infer from the premise, but by De Morgan would be not A and not if B then C. In conditional exchange, remember, the premise in going from right to left will be a disjunction with a negated left disjunct. Whereas in using De Morgan's, the premise will be a negated disjunction, right? She's saying the form and bringing attention to the difference of the form. So, right, the premise in going from right to left will be a disjunction with a negated left disjunct, right? That is a statement of this form. A disjunction with a negated left disjunct. That is what the right-hand side of the form. So going from right to left, that's how that is. All right, now my favorite part of this chapter and perhaps the whole course is sections 3 and 4 of this unit 8. These proof bits. Section 3, constructing simple proofs with replacement rules. I also call this section the proof bit section. You're introduced here to the first two, and here to this list, 3, 4, 5, 6, this goes down to 13. There's 13 proof bits, and I'm going to spend a lot of time on these and the application of these, which come in the examples in section 4. So section 4, I'm going to do on the board for you. Probably do this one, and I will definitely be doing I and J. All right, she sort of does them for you, but I'll be running through. You'll see me run through the thinking for them, because these are problems which require you to see the application of the proof bit. You'll be at a place where you're working backwards, where you see that you need to get from, basically, especially this one here, you need to get from, say, the negation of a formula to the negation of a conjunction, right? Well, they'll see you'll be in a situation in a proof where you'll have a negated. In working backwards, you'll figure that to get home, you need to derive a negated conjunction, and you'll need to notice that you have given the negation of one of the conjuncts. You need to get a negated conjunction. And amongst the premises, so this is the form of what you need, amongst the premises you have the negation of one of the conjuncts. And you need to be aware in that situation that there is a subroutine or proof bit, right? A proof root that can take you from statements of this form to statements of this form. That is, that if you have the negation of one of the conjuncts, you can derive by a little addition trick, the negation of the conjunction. So for all these proof bits, now all these proof bits, as she introduces them, she says they're like subroutines, right? They're like little subroutines you can use. Something like subroutines in computer programming. They can always be inserted into a proof to get a certain result. And you need to, so all these proof bits are presented, you'll notice, in terms of sentential variables, right? P's and Q's. And here it is absolutely crucial this is why I love this part so much. It's absolutely crucial you understand these in their full formality, in their full generality, right? It's P's and Q's, sentential variables that take as substitution instances any formulas of any complexity. So if you need to notice, and I'll do some on the board in a minute, I'll do proof bit 3 on the board and give you a sample application of it. But you need to be able to see that when you have, right, if you see that what you need is a negated conjunction, where the negated conjunction that you need might be with a big, long, complex, ugly P and a big, long, ugly, complex Q. But nonetheless, what it is a negated conjunction that you need. And if you also have, in the premises, the negation of one of those conjuncts, what you need to know, and the knowledge you need to derive from this section of proof bits is, you need to be aware that the path is available to you from the not P to the not P and Q. That's the most important bit. And then, of course, the other thing you need to know is how to get from there to there. That bit's kind of easier, right? But also for all of these proof bits, say them in, process them for meaning, right? And think of the truth table, the truth tables for each of these things, right? So, because if you think of them in this semantic way, in terms of when these formulas are true and false, you should recognize that there should be such a path from the left-hand side to the right-hand side. That is, right, because what is this? This is, the conclusion here is the negated of a conjunction. So it's telling you that it's not the case that both P and Q are true. Well, I should be able to get from the negation of P to the negation of P and Q. Because if P isn't true, if P is false, then definitely P and Q is false, right? That does follow. I should be able to get from there to there, and you can, right? Similarly, right, just take another one here. If you're given as premises, number 11, P and not Q, what does that mean? It means P is true, and Q is false. If P is true and Q is false, think of the truth table for the hook. The truth table for the hook is, it's false, it's only false when P is true and Q is false. So these two facts, as it were, tell you that P and Q is false, and that's what this formula is. But how do you get from here to here, right? You need to know what rules you're going to use. Right? There's going to be additions and also, a lot of addition tricks. And I'll show you how to do them in the board, but that's how you got to think these, okay?